The cosmos just sent us a time capsule, a visitor from a star system likely older than our own sun, and for months the world was mesmerized. When it was discovered, it was labeled a comet, 3I Atlas, the third interstellar object ever found passing through our solar system. The media chatter quickly escalated, asking the tantalizing question, is this just an icy rock, or is it something more, maybe even a piece of alien technology? Now, NASA has finally released its official findings, its most detailed images yet, and the top-line conclusion is clear. This object behaves like a comet. It looks like a comet, and they officially call it a comet. They've debunked the alien spacecraft rumors, suggesting the widespread speculation was simply nonsense. Case closed, right? A sigh of relief, the mystery is solved, we all go back to normal. But wait a minute, because that simple, satisfying answer is exactly where the real story begins to get unsettling. We need to look past the headline, past the press conference soundbites, and right into the data. Because while NASA might have dismissed the sensational claims of an alien ship, the very same scientists who studied 3I Atlas are now pointing to a series of undeniable, deeply strange features that still make no sense. The object may not be an alien probe, but its behavior is absolutely not standard cometary physics. We're talking about strange chemical ratios that defy known solar system formation, and most recently, bizarre, perfectly straight lines jutting out perpendicular to the direction of the sun, a geometric anomaly that makes no sense for a spinning, outgassing rock. This isn't just about a fuzzy ball of ice. This object, confirmed as an interstellar visitor, is a window into a foreign solar system, and what we are seeing through that window is fundamentally different from our own celestial neighborhood. When an object from another star system exhibits behavior that challenges the very rules of physics we thought we knew for comets, it raises a question far more serious than whether or not E.T. is on board. It makes you wonder, does this strange object carry an intrinsic warning about the composition of our galactic neighbors? Are we seeing evidence of physics we haven't accounted for, or maybe a material composition that could pose an unknown risk? Stick with us as we dive into the data NASA doesn't want you to overlook, uncovering the 5 key anomalies that prove 3I Atlas is not just a comet, and why that undeniable difference should make us all look up a little more closely. The official announcement from NASA was a textbook exercise in public reassurance designed to deflate the runaway rumors of alien technology. They released a torrent of images, a collection of observations captured by a dozen scientific platforms across the solar system, including the Hubble and the James Webb Space Telescope. The key takeaway they wanted everyone to absorb was the unmistakable presence of a coma, the fuzzy, telltale atmosphere of gas and dust, and a distinct tail. This visual evidence, they insisted, is the undisputed fingerprint of a comet. It looks like a comet, therefore it is a comet, and the highly hyperbolic trajectory simply confirms its interstellar origin. They emphasized the lack of technosignatures, a crucial term meaning there was no observable evidence of intelligent construction or engineered signals. This was the scientific community drawing a hard line, asserting that the object's exotic nature was purely astrophysical, not artificial. This formal confirmation was necessary, a clear attempt to restore scientific gravity to a conversation that had veered into sensationalism. But here is the critical pivot. The absence of a technosignature does not equate to the absence of an anomaly. The problem lies not in what it is not, but in how strange what it is remains. The very data they use to confirm its cometary nature also contains the seeds of deep, persistent doubt for anyone who looks closer. We must treat the NASA statement as the first layer, the simple conclusion, and then we have to peel back that layer to expose the contradictory facts lurking beneath. It is not enough to simply accept the comet label when the object in question behaves like no other comet we have ever studied. Before we can appreciate the object's weirdness, we have to understand its profound significance. 3I Atlas is a relic, a true time capsule. It has traveled for perhaps billions of years, a voyager from a star system potentially much older than our 4.5 billion-year-old sun. The very fact that it survives this journey relatively intact and active makes it a literal sample of the deep galactic past. It's not just a passing rock, it's the only third object of its kind we have ever confirmed. The initial thrilling discovery was made by the Atlas Survey, the Asteroid Terrestrial Impact Last Alert System, confirming its extreme hyperbolic path, which meant it was not gravitationally bound to our star. This interstellar trajectory is the object's most certain characteristic, the foundation of its identity. Its speed is phenomenal, zipping past Mars at incredible velocity, a pace that guarantees a one-time flyby, never to return. This urgency is what drove the unprecedented all-hands-on-deck observation campaign involving instruments from Earth, Mars orbiters, and deep space probes like Lucy and Psyche. Scientists knew this was their only chance to analyze pristine material formed in a different stellar cradle. The rush to collect data against a disappearing clock, the knowledge that this window is closing forever, heightens the stakes of every observation. Now focus on that concept of a pristine sample, because the deeper we look into its chemical makeup, the more startling the differences become. This object is supposed to be a standard comet from another system, but its composition suggests the rules of chemistry might be different across the galactic neighborhood. The first and perhaps most foundational anomaly is buried in the object's observed chemical signature. Comets formed in our solar system have a relatively predictable ratio of elements and molecules, dictated by the chemistry of our initial stellar nebula. When 3I Atlas outgasses, creating its coma, we can analyze the gases, and here is where the story truly breaks from the norm. We see unexpectedly high ratios of nickel without an accompanying signature of iron, which is chemically puzzling. Iron and nickel almost always condense together in natural, undifferentiated celestial bodies. Finding one without the other suggests a process that is not entirely natural, or at the very least, a geological or chemical differentiation process unlike anything we've observed in our own comets. Even more telling is the ratio of carbon dioxide to water, which has been reported as unusual compared to the solar system comets we are familiar with. It is different, significantly so, and a difference in the fundamental ingredients of a comet is a difference in the fundamental ingredients of a star system. What does this tell us? This composition is a direct link to the conditions of its birth, a place where the ratio of carbon and water ice was wildly different from ours. This is where the warning sign starts to flicker. If other solar systems are built from a chemistry that is inherently unstable or radically unlike our own, what does that imply about the commonality of stable, life-supporting environments like Earth? The object is confirming an alien chemistry, an inherent dissimilarity at the molecular level, and that is a profound finding we cannot simply dismiss. One of the key moments that fueled the early speculation, the moments before the official debunking, was the sudden, inexplicable drop-off in activity. In the early stages of observation, as 3I Atlas approached the Sun, its coma brightened and expanded as expected. But then, for a period, it seemed to fade, almost as if it had fragmented or simply stopped outgassing, disappearing from the expected visual track. This led to serious published speculation, even by respected researchers, that the object was exhibiting non-gravitational acceleration, that something was actively pushing it, not just the passive pressure of sunlight on dust. If a standard comet's icy core fragments, its activity typically spikes, a last gasp of sublimation before its disintegration. 3I Atlas's behavior was more like a controlled shutdown, a mysterious pause in the outgassing process, which later resumed. This temporary vanishing act was a powerful psychological hook for the public and a deep puzzle for astronomers. It introduced the possibility of an internal structure or mechanism that could throttle the release of material, a concept that simply does not align with the model of a simple, uniform ice ball. This is the ultimate why in the 3I Atlas story. Why the sudden temporary cessation of activity at a time when solar heating was only increasing? It suggests a complex internal structure we cannot see, a mechanical robustness that challenges the standard fragility of a comet. The most recent, and arguably the most compelling, piece of anomalous evidence comes from newly released stacked images showing a bizarre geometry in the object's surrounding environment. These are not the grainy, fuzzy pictures the public complained about. These are detailed, long-exposure views that reveal two thin, ruler-straight lines extending for hundreds of thousands of kilometers on either side of the object. Crucially, these lines are oriented at a near-perfect right angle, or perpendicular, to the main tail and the Sun-object axis. In standard cometary physics, jets are caused by the sublimation of ice, and the subsequent pressure from the Sun pushes the resulting gas and dust generally away from the star, creating a fuzzy, curved tail. A comet that is spinning should produce curved or broken jet patterns, not razor-thin, perfectly straight lines. The geometry defies a passive explanation. Harvard astrophysicist Avi Loeb, known for his controversial but data-driven hypotheses, has focused intensely on this, suggesting the lines look like the paths of smaller ejected objects, not the dispersed dust of a standard comet. The sheer straightness and the wrong angle orientation present a significant challenge to the mainstream narrative. It is a visual anomaly that cannot be hand-waved away, an observation that demands we either rewrite the rules of cometary outgassing or reconsider the object's fundamental nature. The appearance of perfect geometry in a chaotic space object is the final sharp hook that locks in the mystery. The sideways jets point directly to another unsolved structural problem, the object's rotation. Ground observations have estimated that 3I Atlas rotates roughly once every 16 hours. If a standard comet nucleus is spewing jets of material from localized spots on its surface, its rapid rotation should smear or wiggle those jets into a visible curve over the vast distances they travel. Yet these newly observed lines are perfectly straight. This demands an explanation. Either the jets are being ejected at a speed so high that the rotation cannot influence their path, or the material is not being released through a standard cometary process. If the jets are that fast, it requires an enormous sustained energy release from the nucleus. If the material is not being released passively, then what mechanism is at play? It implies a rotational stability, or an ejection force that is extremely powerful and finely tuned. The straightness of those lines is a silent contradiction to the simple, spinning ice ball model. We are left contemplating an object that maintains a perplexing geometric order despite the chaotic forces of solar heating and rapid spin. This is not a subtle deviation, it is a direct violation of expected physics, and it forces a choice. Either our knowledge of interstellar comet physics is fundamentally incomplete, or the object possesses an inherent, non-random structural integrity. To truly grasp the significance of 3I Atlas's behavior, we must remember its two predecessors, the only other confirmed interstellar visitors. First, there was Oumuamua, a strange, elongated object that exhibited a mysterious, non-gravitational acceleration with no visible outgassing, which led to the initial, controversial alien probe hypothesis. Then came 2I Borisov, which was much more comet-like, but still showed some unusual chemical ratios. 3I Atlas is now the third data point, and it does not fit neatly into either category. It exhibits the cometary activity that Oumuamua lacked, but it shares the strange chemical differentiation, and now its own set of inexplicable geometric anomalies. The key psychological trigger here is pattern recognition. If 2 out of 3 interstellar objects, the only 3 we have ever seen, show clear fundamental deviations from the behavior of solar system objects, then the problem is not with the individual objects. The problem is with our baseline assumption. It strongly suggests that the materials, the architecture, and the processes of planet formation in the broader galaxy are far more diverse and perhaps fundamentally different from the orderly processes we've charted within our own solar system. This is where the warning sign escalates from a curiosity to a profound realization. Our solar system might be the exception, not the rule, and the galaxy is sending us strange, non-conforming messages. The ongoing debate over 3I Atlas highlights a deep systemic schism within the scientific community, and understanding this divide is crucial to understanding the full story. On one side are the traditionalists, who argue that the known unknowns, the slight chemical ratios and odd jets, must simply be a consequence of different formation conditions. They are cautious, adhering to the principle of Occam's razor, which suggests the simplest explanation is usually correct. It is an exotic comet. On the other side are the proponents of new paradigms like Loeb, who insist that when an object violates multiple established physical expectations, it warrants considering every hypothesis, no matter how speculative. They argue that astronomy has a tendency to pathologize the anomalous, to force new data into old boxes, rather than having the humility to admit the data may suggest a truly new phenomenon. The frustration among the community is palpable. A fleeting, once-in-a-lifetime visitor is showing us secrets, but we are too entrenched in our existing models to truly absorb them. The most important lesson is that science is not a monolithic voice, and the official debunking by NASA is a consensus statement that intentionally downplays the very real, persistent anomalies that some of their own scientists are still tracking. The scientific debate is the proof that the mystery is alive, not solved. So, what is the genuine, non-sensational warning sign we should take from 3I Atlas? It is not a looming invasion, and it is not a direct threat to Earth. NASA confirmed it will pass harmlessly by at a safe distance. The real warning is philosophical and existential. This object is irrefutable evidence that the processes of star and planet formation throughout the galaxy produce objects with fundamental chemical and physical properties that are simply alien to our experience. The unusual nickel and water ratios, the strange, stable geometry, and the unpredictable activity all point to a galaxy where the simple rules of what a comet is are highly varied. The warning is the confirmation of cosmic nonconformity, the realization that our solar system, with its abundance of water and iron, its relatively stable cometary composition, may be an extremely rare and fortunate outcome. It raises the sobering possibility that most stellar nurseries in the galaxy yield chemically unusual or structurally unstable materials. This forces a deeper look at ourselves, compelling us to question whether the conditions for life that we take for granted are as ubiquitous as we hoped. III Atlas is a profound challenge to our cosmological assumptions, a galactic messenger confirming that our home is potentially much more unique than we thought, and that profound difference is the ultimate quiet warning. The story of III Atlas is not over because as it now speeds away, back into the deep interstellar void, scientists are turning to the most powerful instrument available, the James Webb Space Telescope. Webb, with its unparalleled infrared vision, is the key to unlocking the deepest secrets the object carries. As III Atlas moves farther from the Sun, its activity will wane, making it harder to spot. But Webb is perfectly suited to capture the subtle thermal signatures and the composition of the solid icy nucleus itself, not just the dust in its coma. The final push to gather data is focused on confirming the exact structure of those sideways jets and locking down the true ratios of its molecular constituents. The observations from Webb are the final insurance policy, the last chance to answer the unresolved questions of the straightness, the missing iron, and the unusual acceleration. If the new data confirms the existing anomalies, the debate will be irreversibly shifted, forcing a new paradigm in how we view interstellar objects. The end of this chapter is just the beginning of a new scientific understanding, one where we use the passing of this strange visitor to redefine our place in a much more chemically exotic galaxy. The ultimate legacy of III Atlas will be its insistence that we look closer, that we do not dismiss the anomalous, and that we prepare for a universe that is far stranger than we have imagined.